Hello guys, welcome to Hardcoder. Today we are going to see the lead code problem number 1239. Let's dive into the question. Lead code 1239, maximum length of a concatenated string with unique characters. The problem statement is you are given an array of strings ARR. A string S is formed by concatenating subsequence of ARR array ARR that has unique characters. Return the maximum possible length of S, that is the formed string. So a subsequence is an array that can be derived from another array by deleting some or more elements without changing the order of remaining elements. This is the definition for subsequence. So let's quickly watch through the intuition. So let's go to the paint. So let's consider the first sample. So before moving on to the approach, let's define the problem. So the given problem is you'll be given an array of strings. So from it you have to choose subsequence. So you need to choose the subsequence. So what is subsequence? Subsequence is nothing but from selecting elements from the now we will consider subsequence of array. So subsequence of array is nothing but choosing elements of the array or choosing elements or without choosing it. So for example, we can this is a subsequence. So 1 0 1 2, the indices, this is a subsequence, and 0 1 is a subsequence, 0 2 is a subsequence, 0 is a subsequence, 1 2. So what are all these? So 1 2 also a subsequence. So what are these subsequence? So for each element, each index, we have two ways, that is to skip it or to include it. So when we consider the first subsequence, we have never skipped any elements. So in second subsequence, we have skipped the second index. So in third subsequence, we have skipped first index, and in other subsequence, we have skipped the 1 2. Here we have skipped the indexes 0 and 2, and in this subsequence, we have skipped 0th index and first index. In this subsequence, we have skipped only the 0th index. So we have ability to skip or include, so without changing the order. That is the main point in the subsequence. So I think you have got the idea about the what is subsequences. So the given question is find the subsequence of the array, and the chosen subsequence should have only the unique characters. So we have to build a subsequence of the given array, and the subsequence should have only the unique characters, and you have to return the maximum possible length of the formed subsequence, max length. So this is the problem, and in problem you will be given only the lowercase characters. This is the point to be noted, and the length of the array is going to be 16. So how can we approach this question? So firstly, the brute force approach comes to mind is brute force is to try out every possible subsequences. So as I have discussed earlier, so we'll be trying to form every subsequence, and finally for each time we will be storing it in an array, that is the visited subsequences, and finally we'll check if the formed subsequence is a valid case, so valid or not. So how can we check if it's valid? Valid means the chosen indexes should have indices words should have only the unique characters. So we can find it using a set. So then we will be able to find the longest subsequence. So we'll, for each time when we reach the final index, we'll be checking with the whether it is valid. If it is valid subsequence, we'll check with the max. So we'll keep max as global variable, and each time we'll be updating max. and finally we'll be able to get the solution. So the time it takes to run this approach will be, time complexity of the approach is, we go of length of array, let's say n, into the number of characters in the given of any word. So it will be let's say for sorry, 2 power n, 2 power n. So we are trying every possible combinations, right? So 2 power n into the max length of the array, length of the each words. So length of every word, every word, that is what will be the length of the every word. So the given problem, they have said that the length of each word will be 26. So 26 into 16. So it will be again let's say, so n length of each word be, so every word be n into 26 for worst case. So n will be constant, and so the time complexity will be big of 2 power n. So can we have a better approach than this? So the answer is yes. So how can we build it? Let's see. So the approach we are going to use is bit manipulation. So how are we going to use the bit manipulation? So firstly we'll erase it up. So how are we going to use the bit manipulation? So we can clearly see that for each word the maximum characters, that is 26. So for integer there are 4 bytes. The memory for integer is 4 byte, and that is equivalent to 4 into 1 byte will be 8 bit. So 4 into 8, that is 32 bits. So integer will have 32 bits. So we can use this property to store the value of each character. So how can we build this up? So firstly we'll be storing let's say a will have the bit value as 0 and b will have a bit value of 1. So let's see, let's diagrammatically represent the bit value of integer. So this will be 0th bit, first bit, for we are counting from least LSB, that is least most best. So then 2, 3, 4, 5, it goes on up to 31. So we'll consider the index 0th position as for A, and for B we are choosing 1, and for C and for D we are choosing 3, and it goes on up to let's say 20, 0, we have started from 0, so 25th character, let's say 25th character will be for Z, representing with will be representing the Z. So this is the case we are going to use here. So for let's say for U, the ASCII value will be for U is, let's say, check in the Google. So ASCII of U. So ASCII for U is 117. So 117 minus 97. So which will be, for to represent each to find out the position of a character, we'll use reduce the character's ASCII value by 97. So use ASCII value is 117, we are minusing it by 97, so it will be 0 2. So 20 bit we'll be using for U. So for first character, the U bit and N bit will be 1. Other bits will be 0. So other remaining bits will be 0 up to A. This will be A. So other bits will be 0. So only the position of U and N bit will be 1. So for IQ, the same process goes on. So for IQ, we'll have another integer, and for ith it will be 1, and for Q, so Q will be in left. So Q and I, it will be 1. So other bit will be having 0. And for UE, for third index, so u will be having 1 and e will be having 1, so other bit will be 0. So 0 0 0, this will be a, it will be the z, let's say that 28 bit, 25th bit. So this will firstly form the bit representation of each word. So there's a corner case in while representing this, when we have both we have duplicate words, will duplicate characters in the word, we'll consider the encoder value as 0. So we'll call the value of this as encoded value. So encoded value of a word, of a string having duplicate characters will be 0. Otherwise, it will be having a proper natural number value. So this is the condition we are going to use. So after finding the encoded value, we'll store the encoded value each let's say encoded val into a integer array. So we'll be storing the encoded value of n. Let's say n is array's length, ar or dead length. So we'll be firstly storing the encoded value for each of the words, and finally we'll try out the 2 power n combination. So after applying this, approach becomes much simpler. So it will be just consuming 2 power n space, 2 power n time. So if you are not able to get the approach, you will be clear in the coding section. So let's dive into the coding section. So firstly, we'll create a encoded, well, okay. So for each, firstly we'll store the encoded value. Let's pass the error and encoded well. So after storing it, we'll return the max length of, we'll pass the error encoded value, encoded array, and current index and current value, let's say 0. So let's have the error as private value, global variable, so that the max length function will have just the parameters which will be readable. So let's say of, so firstly mention we'll store the global variable. So firstly we'll store the encoded values, right? And encoded value. So for each words, we need to find the encoded value. So encoded value of I will be encode. Let's have a helper function encode of here dot get I. So helper function will be able to return the encoded value. So for helper function encode, we'll get the string yes, and we'll have int, let's say encode value as, firstly we have 0. So for we'll iterate over the each character of the string, so we'll get the character. So we're getting the character and storing it into the reference ch. So after finding the character, we need to check if the encoded value has already previously have the occurrence of the character. So let's have a temp which will be finding the value in position of the current character. So how can we find it? CH minus 97. So this will be the position. So we'll power this up with 2. So it will be math dot power of 2 comma 2. So after powering it up, we'll check if temp has already previous occurrence or not, of current character or not. How can we find it? We'll check using temp, and if temp and encode value is 0, not equal to 0, it will be a case where the character is already visited. So in that case we'll return 0, or else we'll and the we'll or the temp value. So how can we it up? So encode value plus a temp value. So we can use this formula. So it will be we have named the encode as encode function. So after this, final function is max length function. So we are going to write the max length function. So private, it will be returning int value. So max length of int encode value and current index and current value. So if we have reached the final length, we'll firstly check with the return the 0, else uh, we'll skip the current word. So how can we skip it? So let's call a max value, and we'll pass the encoded value function, encode value array, along with we'll increment the ith pointer and pass the same current value. So firstly we have max, and finally we'll have we'll include the current word. So for include, max will be, so firstly before including we need to check if the current value has previous occurrence of encoded value. So check current and encoded value of current word is 0 or not. If it is 0, we'll check, we have we will able get to know that the current word does not have duplicate word which we have included before in the current variable. So we'll add the max will be updated to max of previously calculated map with current words length, that is arr dot get I, which will be returning the current word. So let's store it in a word string. Word will be current word. So this is the current word. So it will be current word dot length plus max length of encoded. We'll pass the array along with incrementing the ith pointer, and current will be odd with the encoded value of current word. So finally we'll return the max value. So let's check it up. So we'll it's showing that the math power will function will return long value. So we're converting it into int value by using typecasting. So we'll have this in a bracket. So in 34th line, so we'll have a bracket. So encoded, so it's encode val. So finally we need to return encoded val. Sorry. Yeah, it's working fine. So let's check with the other test cases. Let's submit it up. Sorry. So we have used this encode val temp, and encode val is not equal to 0 will return 0, right? So what should we do now? So firstly, for the first condition is we check if the current that is encoded val not equal to I. I mean not equal to 0. Why are we checking this condition? This condition is to ensure that the current word does not have any duplicate characters in it. So let's check it up. So if encoded val of I is 0, what happens here? So sorry, not equal to 0. So we have to skip the invalid words, right? So we check with the condition which test case which we had struck. So it's working fine for the test case. So let's submit it up. Yeah, accepted. And the time complexity for this approach is order of 2 power n, and space complexity is u of n, since we use extra array of size n. So approach for this question is recursion and back bit manipulation. So thanks for watching this video. Have a great time.